The chapter is too long. We won't be able to finish within time. So let's start reading first. Jishan, Sahim, can any one of you start? Yes, please do so. Start reading. Hello. Start reading, beta.
Yes,
You start.
trust and pressure in everyday life. Pressure exerted by a brick, a stretched brick kept on the ground exert less pressure than a brick kept on the ground in standing position. This happens because the surface area the of
Contact.
contact brick in stretched position is more in comparison to the brick in standing position. As we know that pressure increases with decreases in surface area and vice versa. Thus, in the case of stretched position, a brick exerts less thrust over the ground in comparison to the brick kept in the standing position.
So we had already seen this is the break in the standing position and this is the break in stretched position. Remember? Where will the more pressure? Here, obviously. A and B. Where will you find more pressure? Obviously, A, because it is in the standing position. So less area, more pressure. In B, more area, less pressure. You understood? All of you? So if area is less, pressure will be more. This is what has been taught in the first instances. Let's see the next example. Please start.
Camels can run easily over the sand. The the feet of a camel are large. Larger feet mean larger area, which result in low pressure. Due to this, camel
Camel,
can
camel,
easily walk on sand with sinking its feet.
without. Okay. Similar case you find in camel. You know that they can run on sand. How come? Because the feet of camel are very large. Now, if it's larger feet, that means the area is large. And if the area is large, that means the pressure is low. If the pressure is low, that means the feet is not sinking in the sand or in the desert. Hope you have understood. And that's the reason why camel can walk easily on sand without its feet sinking. Any problem? All of you understood? Hello? Are you understanding?
Yes.
Okay. Now we will see the third instance. Yes, start. Please start. Please read, better. Hello?
Yes,
Yeah, please start reading.
tank easily can run over sand and mud. Caterpillar tracks surrounding the wheels provide a large surface area. Due to this, a tank can move on any
Terrain.
terrain without sinking.
Same thing is observed in tanks. Tanks, artillery. Tanks that is used for war. Those are called as tanks. Now, those tanks can easily run over sand and mud. They can move anywhere. They can even move on small mountains. They can even move in valleys. There are tracks. Tracks means you can see the grooves on tires. These are the tires. You can see these tracks, on tires. So there are caterpillar tracks surrounding the wheels. Now that track is giving a large surface area to the tire. We know that if the say area of the tire is large, the pressure will be less. So it's a huge tank. It's got so much of weight. In spite of that, it does not sink in the ground. You understand? Hello? It does not sink in the ground because of this caterpillar tracks. Okay. D. Please start with D.
Tractor has broader tires. Tractors are made mainly for agriculture purpose. Because of broader tires, a tractor exerts less pressure over the ground as a pressure decrease with increase in surface area or contact Hensley easily runs over the muddy field.
Similar case we can find in tractors. We know that tractors have got broad tires. Where are we using tractors? For agriculture. Now, when we know that tractor has got broad tires, that means it is only giving less pressure to the land or the ground. Okay? So when it is giving less pressure on the ground, so it runs over even the slippery field or the muddy field, which is soft field. And the tires don't sink in the muddy ground. You know that muddy grounds are very soft. So it has got lots of weight. Tractor, it should sink in the ground. But why it is not sinking? Because of the tires, which are very, very wide and big. That's the reason why it does not sink in the muddy ground. Let's say another example. Yes, better. Please read. Please read. Hello. Can you hear me?
Yes, ma'am.
Yes, please read. Please read, better.
One end of a nail is pointed. When a nail is pushed in a wall or wood, it is pushed from pointed side. Because of pointed shape, nail exerts more pressure over the wall or wood and is easily pushed by hammering.
This instance we have already seen. This is the broad end and this is the pointed end. Remember how we push it in the wall or wood? By pointed side. We know that, right? Because of this pointed shape, it is exerting more pressure on the wood and it goes inside. You understood? Because the surface area is minimum. Here the surface area is minimum. Here the surface area is maximum. You understood? Because the area is minimum over here and area is maximum over here. And we know that if the area is minimum, the pressure will be maximum. As the pressure exerted is maximum, it easily goes inside the wood. Okay? Let's say an example. Start.
The straps of school bag are broader, since large surface area exerts less pressure. Therefore, school bags with broad straps exert less pressure over the shoulder of a student, while being slung over the shoulder and the student feel it easy to carry even a heavy bag with more books.
Now you can see this. This is your shoulder, right? This is your shoulder. Now you're wearing a bag, a school bag with wide shoulder straps. Okay, that means area is big, pressure will be less. So it's easy for you to carry the bag with so many books. And if you carry a thin strap bag with books, where will be more pressure? Less area, more pressure. That means your shoulders will start paining because pressure applied will be more by the thin strap bag. Understood, beta? Did you understand?
Yes.
The last example. Let's see. We have all studied all this thing. We're just winding it up. A summary how area and pressure are interrelated. Yes, please start.
Knife with sharp edge cuts easily compared to one with blunt edge. Knife with sharp edge exerts more pressure because of less area in contact with an object, such as vegetable, and hence it cuts more easily than a knife with blunt edge.
Similarly, a sharp knife cuts easily. A blunt knife does not cut. Simple. Sharp knife has got less area, more pressure. Blunt knife has got more area, less pressure. As simple as that. Any problem so far? These were all the examples of area and pressure. Have you understood, all of you? Boys, if you can hear me, please answer.
Yes.
All
Yes,
of you
ma'am.
understood? Yeah,
Yes,
all of you
ma'am.
understood? Examples,
Yeah,
fine.
ma'am.
Thank you. Now we're going to work on pressure in fluids. Let's make it fast better because these are all repetitions so we can wind it up as fast as possible. Please do so. Start.
Pressure in field. The substances which can flow easily are called fluids. All the liquids and gases are fluids. Like solids exert pressure due to their weight, liquids also have weight and they exert pressure. But a fluid, liquid or gas exerts pressure in all directions, sideward, downward and even upward.
Okay, that's it. Let me explain this pressure in fluids. What is written? Whatever substances which can flow, which can move easily, they are called as fluids. So that means the gases and liquids are fluids. This is what you have to understand. We are using gases also as one of fluids. Okay? Now we know that solid exert pressure. We know that, right? Because if you put a brick on a table, it is exerting pressure on the table. As simple as that. Same way as solid exerts pressure because of the weight, liquids also have weight. You can measure, isn't it? Milk, oil, you can measure it. Can you? Hello? Can you measure oil, milk?
Yes.
Yes. So they have weight. And if they have weight, they can exert pressure. As simple as that. But always remember, let's take a balloon. Okay, let's take a balloon. I'd already told you that balloon exerts pressure onto the wall, and that's the reason that they get inflated, isn't it? See, it is blown because it is exerting pressure in all the direction of the wall of the container, that is the balloon, and the balloon gets inflated. It's blown. Okay, so this is how it is exerting in all direction. This is air. I'm talking about air. This is gas. Let's talk about liquid. I take a container, I fill it up with water. What is water doing? Water is exerting force on sideways. Yes. It is exerting force downwards. Yes. It is exerting force upwards. You understood now? Did you understand this? How liquid is exerting pressure in all direction, sideward, downward, and even upward. This is what has been explained. Now we come to another terminology that is called as buoyancy. Let's start. Please start. Hello. Start to read better. Can you hear me? Zishan, Shaheen, others, Salman. Any of you start reading, please. Start reading.
Yes, ma'am.
Start.
When an object is placed in a liquid, the liquid exerts an upward force on it. It is easily to lift a stone
Lift,
as
lift, lift.
long as
It is lift.
lift lift a stone as long as it is inside water, but feels heavy if it is lifted above water. A mug of water inside the water appears lighter, but it feels heavier when lifted above the water.
Yes.
There- Therefore, the objects appear to be less heavy when
Submerged.
su- submerged,
Submerged.
submerged in liquid than they are in air. This shows that every liquid exerts an upward force on the object immersed in it. The tendency of a liquid to exert an upward force on an object placed in it is called buoyancy.
So what is buoyancy? You can see this examples in day-to-day life. That whenever you take a mug and put it in a bucket of water, that time you don't feel that you're carrying a mug. But as soon as you fill the mug and take it out of water, you can feel the weight of the mug. Did you? Do you feel this? Hello. Do you feel it? Okay, fine. So when the mug was placed in the bucket of water, the liquid, that is the water, was exerting an upward force on the mug. When you place something inside the water, you don't feel the weight of that subject or the object. But as soon as you take it out of water, you can feel its heaviness. So, what do we assume? That whenever objects are placed in water, it appears to be less heavy when it is immersed in liquid, when it is submerged in liquid, as compared as it was in air. Like if I'm holding a mug in the air, I can feel the weight of the mug. But as soon as I immerse it, as soon as I submerge it in water, I don't feel the weight of the mug, which shows that every liquid, it could be anything, XYZ, it is giving an upward force on the mug or on any object which is immersed or submerged in the liquid, whether it is partially or wholly. This tendency of exerting and pressure by the liquid on any object is called as buoyancy, and that's the reason the ship moves, the boat moves on the water. Do you understand? Because the water is exerting force onto the boat or ship and it allows it not to sink in the water. Hope you have understood what is called as buoyancy. For example, let's see over here. Now, this is a container with water. Okay? And I hold a stone attached to a string. I can feel the weight. As soon as I immersed it inside the water, I will not feel the weight because there is an upward force applied by the water. This force on the stone is called as buoyancy. We will always get this buoyancy when we are working or talking about a fluid. When we are talking about liquid, then only you get buoyancy, and nowhere else you will get buoyancy. Okay, so buoyancy is observed only in liquid. You understand, boys? Do you understand?
Yes.
Hello, all of you,
Yes.
all of you. Okay, we will do the revision part with this slide. Please carry on. Please. Hello. Start reading better.
Pressure in fluids. Any solid object exerts pressure because of weight. Similarly, since fluids also have weight, thus they exert pressure. Gas and liquid both are considered as fluids. Fluids exert pressure in all directions over the inner walls of a container in which they are kept.
Fine. Do all of you agree with this? This is just a revision. Whatever we did earlier in earlier slide, this is the same thing in
Yes.
different wordings, right? The words are different, but the meaning remains the same.
Mm,
All of you understood?
yes.
Okay, so it's a revision. Okay. Now we'll talk about buoyancy. Start.
Buoyancy is the upward force exerted by fluids over the surface or of contact of an object which is immersed in fluids. But Buoyancy is also known as upward thrust.
Just a moment. Now we have talked about thrust. Now we are going to talk about upward thrust. So any force which is on the object which is immersed in the water. For example, this is the object and the whole thing is water. This is called as buoyancy. And because it is moving towards up, it is called as upward thrust. Okay? Upward force. So buoyancy is always towards upward direction. Fine. Let's start.
Why does an object sink or float over water? When an object is immersed in water, it exerts pressure over water due to its weight. At the same time, water also exerts upward thrust over the object. If the force exerted by the object is greater than the upward thrust or buoyancy by water, the object sinks in water over
Otherwise,
otherwise it floats over water.
okay. Now the question is, I'm showing you two example. I take a stone, maybe a big stone. I take a small stone. Okay, just I'm setting an example. If I allow it to get inside the water, the stone may settle at the bottom, right? If I allow this small stone immerse in the liquid, it may float on the surface of water. So this is A and this is B. Why so? One is sinking and the other one is floating. Because the stone has got weight. You agree? All of you agree, beta? The stone has got weight of its own. Yes or no? Hello? The stone
Yes,
is, right? So due to its weight, the force applied to the water is more than the upward force, and hence it sinks. So it sinks. So this is more than upward thrust. In case of floating, the weight of the body is less than the upward thrust of the water, and hence it floats. Did you understand?
Yes.
There are two forces applied. One is the weight of the object, and the other one is the upward force of the water. You understand? If the weight of the object, that's the force, right? Weight of the object is force. If that force, that is the weight of the object, is more than the upward thrust of the water or any liquid, so obviously it will sink. Whereas if the weight of the body is less than the upward thrust of the liquid, obviously it will float. Understood? Hello? Did you understand? So there's two forces acting onto each other. One is the weight, and the other one is the upward thrust by the liquid or the buoyancy. Any problem? Have you understood this mechanism? Why a body sinks or float? All of you understood?
Yes.
Thank you. Can we start again? Again, this is revision of whatever we did just now. Please start, Peter. Any of you can start,
Pressure.
please.
Pressure in fluids, liquid and gas. Fluids exert pressure on the base and wall of container. Fluids exert pressure in all directions. Pressure exerts on fluids is transmitted equally in all directions.
What we saw that fluids means liquid. For example, this is the container. Okay, so what it is doing, it is exerting pressure on the base. Now this is the base, the bottom is called the base, and walls, this is the walls of the container. Yes or no? Is it clear? Hello,
Yes.
is it clear now? So I put liquid in the container where it is applying pressure, better bottom and on the sides of the container. Okay, this is liquid or fluids. Now that fluids can be gas or liquid, right? I told you gas all over. There is liquid sideways, downwards, and upwards. Have you understood? This is what I have taught you. This one, balloon, it is all the directions, right? Force is applied in all the direction. Gas, whereas in liquid, it is sideways, bottom, and upwards. Okay. Now we are going to talk about upthrust. That is the upward force. Please.
When an object is immersed in a fluid, it experiences an upward force called buoyant
Point.
force. Buoyant force. This property is called buoyancy or upthrust. The force of gravity pulls the object downward, and the buoyant force pushes it upwards. The magnitude of the buoyant force depends upon the density of the fluid.
Density.
Density of the
Density.
fluid.
Okay. Density means how thick the fluid is.
Yeah.
What did I say? How thick the fluid is. So you can see over here, this is the substance, object. The object is pulled towards the earth. Why? Because it has got weight. Is it? It has got weight. And hence the gravitational force is working on it. So it is pulled down. So the gravity is pulling down, but the buoyant force is pushing up. Have you observed this? Two forces are acting on an object when it is immersed in the fluid. What is that? One is the weight due to gravity. Second one is the that is downward. The weight due to gravity is downward, and the buoyant force by the liquid to the object is upward, or the upward thrust, that is called as buoyant force. So two forces acting on an object when it is immersed in a liquid. One is weight, which is moving downward, and the other one is buoyant force by the liquid to the object, which is moving upwards. Any problem? It's just a revision part. Any problem?
No.
No.
Okay, thank you. Something more about buoyant force you will read now. Let's make it fast, Dutta. Please. Actually, I'm taking one topic and making 2, 3 slides as a part of revision. So the things become quite clear to all of you. Okay? So we'll not waste much of time on redoing things or explanation because it's already been explained by me. Please read better.
The upward force acting on the object immersed in a liquid is called buoyant force. It is called it is also called upthrust.
So buoyant force is equal to upthrust because the thrust is moving upwards. The force is moving upwards. So it is called upthrust or buoyant force. Why it is caused? Let's see.
When a mug inside the water, the pressure from the sides are equal and no net force is available. But pressure at the bottom of the mug is more due to more depth of water is less than at the top due to less depth of the water. The difference in pressure exerts next upward force called upthrust or buoyant force. The mug, usually made of plastic lighter than water, is pushed up due to this upthrust.
Upthrust. Okay. When we try to push the mug in the water, we literally push it. Have you observed that? When it is empty. But when gets filled up with water, it automatically goes down. Did you see this activity whenever uh, you are using, when you are putting the mug inside the bucket of water? Have you ever observed this mechanism? That when it is not filled with water, we literally have to push it in the water. When it gets filled with water, it's so easy to move it inside the bucket of water. Have you observed this? This is only due to buoyant force. Because at that time it was filled with air, so we could feel the weight of the mug. But when it goes inside the water, we don't feel the weight of the mug. Did you understand? And when the buoyant force is more, so we can feel the pressure on the mug. That is the upthrust. That is upthrust is by what? Is by the liquid onto the mug. So we can feel the weight of the mug. You understand? So what are the differences that we are going to see? First, the difference between the weight and the buoyant force. If the weight is more than the buoyant force, the mug will sink. But if the weight is less than the buoyant force, the mug will float. Did you understand? Hello. Did you
Yes.
understand better? Let's start. Buoyancy in everyday life.
Swimming water. Anyone can be able to swim in water because of the upward thrust exerted by water.
So you can swim in water. Why? Because of the buoyancy. Second,
Flying of bird or aeroplane. Since air is a fluid, thus it also exerts upward thrust over the object. Therefore, because of upward thrust of air, a bird or aeroplane can fly in the air.
so why aeroplane and bird can fly in the air? Because of buoyancy, because of the upward thrust of the air. Okay. Let's see what are the factors which affect buoyancy. Please start.
Density of the fluid,
That
volume
means
of the
how thick it
object,
is. Just a moment. Density of fluid is how thick it is. Is it water or is it oil? So oil is more dense than water. Yes.
volume of
Let's see
object,
what.
volume of object, upward thrust exerted by a fluid increasing with the volume of the object immersed in it.
That means if the volume is more, buoyancy will be more. Let's see density.
Upward, thr-
Hello, hello.
Yes.
upward thrust increasing with increase in density of fluid, denser liquid exert more upward thrust.
So it is directly proportional. Dense, liquid, more thrust. Yes.
This is
Continue.
caused that it is easier to swim in seawater rather than fresh water. Seawater is saline. Salt dissolved in the sea water increase the density and hence it exerts more
More.
upward thrust than fresh water.
Now you got the reason that in seawater you can float, but in fresh water you may sink. We may get drowned. You understand? But in seawater we may not get drowned because of the salt present in seawater. Because when the seawater is saline, it increases the density and hence the upward thrust is more as compared to lakes or ponds or river water. You understand? Do you understand why we can float in seawater and we may get drowned in fresh water? This is the reason because of the upward thrust. So, upward thrust is more in seawater as compared to fresh water, that is, lakes. So, we can get drowned in fresh water, but we may swim in salt water, that is, seawater. The things are clear. Is the things clear? The buoyancy and the upward thrust and why objects sink and why objects float. Have you understood all these things? Fine. So we come to a close of today's session. I hope you have understood it very well. Okay. So please be sharp tomorrow at 8 o'clock, Peter. Every day, 5 or 10 minutes we are wasting. I would be glad if you be sharp at 8 o'clock. Okay. It's a request to all of you. Okay, Peter? Hello.
Yes.
Thank you
Right.
and have a good day, beta. Bye.
Yes, ma'am.
Bye. Bye.